We are going to solve next question in this series of Bernoulli's probability. Okay, the next question that we have here is suppose that the number of runs scored of delivery is uniform, same as previously we have seen in another question, 1, 2, 3, 4, 5, 6. Independent of what happens in other deliveries, a batsman needs to bat till he hits a 6. What is the probability that he needs fewer than 6 deliveries to do so? Okay, now each delivery has how many runs just possible. So each delivery has these many runs: 1, 2, 3, 4, 5, 6. Okay. Now the batsman keeps batting until he hits 6. That's another condition. What is the probability? A probability that he hits a 6 in fewer than 6 deliveries. So each number is equally likely. Now there are 6 possible outcomes. Only one is a 6. So probability of getting a 6 is 1 over 6. Okay. And a probability of not hitting a 6, P6 dash, is 1 minus 1 over 6, which is 5 over 6. Okay. Now, what does fewer than 6 deliveries mean? The batsman hits a 6 in the first, second, third, fourth, and fifth delivery, not a 6th or later. So the batsman has to hit a 6 in either the first delivery, second delivery, third, fourth, and fifth, but not 6th, because it said less than 6 deliveries. So probability that the first 6 comes on delivery 1, 2, 3, 4, 5. Okay. Now, as you see, there are 2 outcomes, but you don't have a finite. Although you have 2 outcomes, either the player hits a 6 or does not hit a 6. That's 2 outcome scenario. However, you don't have 5 independent events, finite independent events. You are going to have deliveries which are less than 6. So it can be 1, it can be 2, 3, 4, 5. Here we are not going to use what we have used before, which was binomial trial or probability. Here we are going to use geometric probability. So what is geometric probability? A classic case here. Now let's check. Using this example only, probability first 6 on delivery n. So you are going to hit a 6 in n delivery. Is not hitting a 6, so not hitting a 6, n minus 1, okay, times hitting a 6 in any deliveries, hitting a 6, okay? So to solve this further, let me make some space. I don't think there's space for this question. Yep, now we have space. Let me change the pen. So in this we have Pn. It's not very different from binomial principle. It's just there's one peculiar part. So you have n deliveries here, 5 over 6. You're taking not hitting a 6 as the first element, which is not hitting a 6, which is 5 over 6, n minus 1, times hitting a 6, which is 1 over 6. And why did we take 1 here? Not because we are only talking about 1 6, not any more 6. 1 6 before 6th delivery. So you have 1 here. It is going to be 1 here as well. Okay. When you solve this, then you get a total probability. So this is for n. And how many n we are talking here? We are saying we need to get the probability in the first, in the second, in the third, in the fourth, and in the fifth, but not 6th. So these are 5 cases that we have. We need to find the probability. What is the probability that he needs fewer than 6 deliveries to do so? So his chance of hitting 6 in the first ball, his chance of hitting 6 in the second delivery, third delivery, fourth, and fifth, and so on. Let's first evaluate the first. So it's going to be 5 over 6, n is 1 minus 1 times 1 over 6, 1. This is going to be 1 over 6. 2, same thing, 5 over 6. It's going to be 2. Oh, I'm sorry. And n is 2 minus 1. Okay, times 1 over 6, 1. It's 5 over 36. Third case, we have 5 over 6, 3 minus 1 times 1 over 6, 1. It is going to be 25 over 216. Then you have fourth delivery. It is going to be 5 over 6, 4 minus 1 times 1 over 6, 1. It is 125 over 1, 2, 9, 6. Last we have fifth. And here we have 5 over 6, 5 minus 1. This is the last delivery. Now you have 625 over 7776. Okay, so what's the total probability? If we, again, as I said, why are we adding these individual probabilities to get the total probability? It's because we want to find out what's the probability of getting 6 in one, or the keyword here is or, in the first delivery, or second delivery, or third, or fourth, or fifth. So once we add all these, we get 0.5982, which is 0.60. This is your final probability that you achieve. Okay, then we are going to our next question, a football match between Argentina and Portugal. Argentina and Portugal is going on until the last minute. None of the teams has scored a single goal, so the match referee decided to go for penalty shoot. From Argentina, Messi will go for penalty all the time, and for Portugal, Ronaldo will go for penalty each time. There is 40% chance that Messi can convert penalty into goal, whereas 70% chance that Ronaldo can convert penalty into goal. Each penalty shoot is totally independent of previous one. The two player will go for penalty shoot alternatively, and Ronaldo will start the penalty. If Ronaldo hits the penalty first, then Portugal will win, and Messi will not be allowed to do penalty. Okay, complex question. Given values, we have Messi playing for Argentina. Probability to score on penalty is 0.4. So let's start here. Probability, let me increase the size. Probability of Messi hitting a goal is 0.4. Probability of Ronaldo hitting a goal is 0.7. So what's the sequence? Ronaldo is first. Then comes Messi, then comes Ronaldo, then so on. And penalty shots are independent and continue until somebody scores. Let's say if Ronaldo scores first, Messi does not get to shoot next. The game ends. Ronaldo wins. So now we have question number 2. What is the probability that Messi wins before third round of penalty? That means Messi scores a goal on his first or second turn, and Ronaldo does not score on his attempt before. So round 1, how does round look like? Let me get some space here. I don't think there's space. Okay, let's see. Question 2. Okay, so round 1 we have Ronaldo shooting. Round 2 we have Messi shooting. Round 3 we have Ronaldo again. And round 4 we have Messi. So what is the question here? Messi scores a goal on his first or second turn, and Ronaldo does not. So what is the probability wins before third round? So before third round, Messi wins. Okay, that's the question. Ronaldo does not score, but Messi scores, and that's how Messi wins. Before third round means here, Messi scores by his second attempt. So Messi scored goal here. Ronaldo missed. Sorry for my bad penmanship here. But anyways, ignore my handwriting. Messi scored, but Ronaldo missed. So let's draw the possible sequences. Messi wins on his first attempt, which means Ronaldo misses. What is the probability of Ronaldo missing? Is 0.3. Messi scoring, probability of Messi scoring is 0.4, as we have seen before. So what is going to be the probability? It's very simple here, if you see. Probability that the Ronaldo missed the first round is 0.3, okay? Once Ronaldo did not score, but Messi scored. This is the first attempt. Round 1 means first Ronaldo goes, then Messi goes, then Ronaldo goes, and Messi goes. So this is the round 1. In round 1, what's the probability? Probability of Messi winning will be, Messi is 0.4, so this means he scored, but someone has to lose. Who is losing? Ronaldo. So the probability here is Ronaldo did not score, and here's the keyword. That's why I'm multiplying, and Messi scoring. That's why your total probability in round 1 is 0.2. But this isn't over. This is just the first round. We have to do the second round as well, where Messi actually scored. So Messi scored because before third round he has to win, and before third round means round one we have seen. This is round one, and this is round two. Here Messi has to win again. So Ronaldo misses again, 0.3. In the first round, we have seen Messi won in the first round. Okay, now in the first round, Ronaldo missed, but Messi also missed, because if Messi wouldn't have missed the shot, he would have won the match. But we are going into round two, which means both have to lose. So Ronaldo missed, but Messi also missed. If Messi missed, the probability is 0.6. But then this is the first round. In the second round, we have probability that Ronaldo missed again. Very unfortunate. 0.3. But Messi this time did not miss. He won. So probability is 0.4. So what's the total probability? It's the multiplication. Ronaldo missed and Messi missed. Ronaldo missed, and Messi scored. So it's 0.3, 0.3 times 0.6 times 0.4. The total probability here is 0.1416. Oh, I'm sorry. I added the total one. I'm checking my notes. That's why I'm misled here. The probability here is 0.0216. Very low probability. So now total probability of Messi winning this series or penalty shots are 0.12, which is this one, the first round, and the second round, which is 0.0216, which is 0.1416, or 0.14. So now you can see how difficult penalty is, because in the first round it was easier for Messi to score. But if Messi wouldn't have scored in the first round, it would have become very difficult for him to score in the second and third and then fourth, because then Ronaldo has upper hand. Okay, now let's go to our third question. Third question says, what is the probability that Ronaldo will win? So Ronaldo can win at any of his turns. First try, second try, third try. It's just he has to score before Messi. That's it. Solved question 2 here. We got the answer as 0.14. But before I move ahead to question number 3, which is slightly more tricky, I'm going to describe some principles here. Okay, the principle is sum of infinite series and geometric series. Okay, let's start with geometric series. Geometric series. So I have shown you the binomial probability and binomial trials. Now next is geometric series, which is closely aligned with geometric probability, geometric trials, and all those other topics. So a geometric series is just like keep multiplying something by the same fraction. So in probability, it lets us add up all the rounds without writing forever. So let's take a simple example, which will probably help you. So for example, you have a ball, you drop a ball, and it bounces back. But every time it bounces back, it is reduced by 80% of the height is reduced after each bounce. So let's say if the first bounce is 80 centimeter, the second bounce is going to be 80 centimeter reduced, so 80% reduction in height. That is 80% less than the original, which is 64 centimeter. Third round, same thing. Third bounce, 64 times 0.80, which is going to be 51.12 centimeters. So you see, this is following a pattern. As I said before, it is getting multiplied by the same number, same multiplier, if you will. So what will be the total distance? Total distance traveled by after every bounce is going to be 80 plus 64 plus 51.2 plus so on. It's a never-ending list where you multiply by the same number each step, and this is called geometric series. So now key fact here is if the multiplying number, which is called the common ratio R. So here, what is R? R is 0.8. This is what? A common ratio. So if let's say the common ratio is smaller than 1, in this case it is, the sum settles down to a finite value. If it's less than 1, obviously it's not going to increase, it's going to decrease to a very small number. So what will be the sum? This is infinite series sum. What is the first number? You have first number, any number. It is getting reduced by a common factor, which is R. R is the factor. So let's take here the example. 80 centimeter was the initial number, but it's getting reduced by how much? 0.8 factor. And at the end, you will get something close to this, 400 centimeters. So total distance covered will be 400 centimeter in this case. Now let's come back to question number 3. With this principle in mind, we are going to solve our question. Question number 3. What does question number 3 say? It says, what is the probability that Ronaldo will win? We know there are, in each round, either Ronaldo goes first, and if he scores, he wins. Otherwise, Messi takes a shot. Whoever scores first wins. But Ronaldo has first mover advantage. The answer here is not going to be 0.7 because you see here, 70% chance of Ronaldo scoring a goal does not mean he will win the entire match. That is different. That has another component, and that component is Messi losing. Okay, so let's build some cases. So Ronaldo shoots first. This is what we know. Messi goes second, and each shot is independent. What are the 3 events? So we have event 1, where Ronaldo scores. Ronaldo scores. Portugal wins, and the probability is 0.7. This is very straightforward. In the first round, Ronaldo is going to score, and Portugal is going to win. But let's say what happens in event 2. In event 2, Ronaldo misses. Ronaldo is going to miss. The probability is 0.3. But Messi is going to score. Messi's score is 0.4. And in this case, Argentina wins. Now, probability of Argentina winning or Messi winning is 0.12. There is another event for any given round. So each round has 3 events. The third event is both miss. Ronaldo miss, we know the probability is 0.3, and Messi also misses. The probability of this is 0.4. I'm sorry, it's 0.6, not 4. 0.4 is winning. This is 0.6. So total probability is 0.18. So these are some of the events that we have here. Ronaldo scores first, 0.70. Ronaldo misses, but Messi scores and wins, 0.12. Ronaldo misses, Messi misses, and we go to the next round. Okay, this is very, very simple. This is, I think you have understood the principle behind it. Let me make some more room here so we can solve the problem. Okay. So step 2 will be Ronaldo can win on the first shot is 0.7. Both miss is 0.18 times 70. So let's take round 1. Okay. Ronaldo comes and takes a shot is 0.70. Okay. Now, if both misses, then Ronaldo wins on the next first shot. The first, this is round 1. Ronaldo wins. But what if there's round 2? Both miss. The probability is 0.18. Probability of both missing is 0.18. But Messi, but then the original question was Ronaldo has to win. It's either the first time Ronaldo wins or in the second round Ronaldo wins. So in the first round both miss, Ronaldo, and then you multiply by Ronaldo winning. So Ronaldo winning is 0.7. But what if we go to round 3? Round 3 means in the first round both miss, in the second round both miss, but in the third round Ronaldo comes again. So it's 0.18 first round missing, 0.18 second round missing. In the third round Ronaldo wins. Let's go to round 4. Round 4 means in the first they miss, both miss. In the second both miss. In the third both miss. In the next Ronaldo comes in. But you will ask, why Messi? What if Messi wins? If Messi wins, this does not make any sense at all. This problem does not make any sense because if Messi scores, then he wins. The loop stops. You're not going to next round. It's only when both of them miss and then Ronaldo takes a shot. So if you follow a pattern, you will see what is R here. You will see something common in all these questions, which is 0.8, 0.8, 0.8, 0.18, 0.18, 0.18. This is your R, as we talked before. This is a geometric series, and 0.18 is the common R. All right? And so how does this pan out? every round has individual probability, and total probability will be the sum. So if you do the total probability, it will be 0.70 plus 0.18 times 0.7 plus 0.18 times 0.18 times 0.7. Okay, so you see a pattern here. What we are going to do is take 0.7 common. It's going to be common, taken common in all those individual expressions, and you will get 1 plus 0.18 times, oh, sorry, not times, but plus 0.18 squared plus 0.18 cubed. Okay. Now you have to take the geometric series sum of the infinite series for this. This has to come down to some number because it's decreasing, it's not increasing, right? So it will come down to some finite value. And what is that? Initially, it started with 1, so we are going to write 1. As you remember, initially the number here was starting from 80. Here it's starting from 1. 1 minus, what is another number? 0.18. And what are we getting? We are getting 1.2196. Okay, this is the final value. This gets multiplied to 0.7 times 1.2196, and your total probability is going to be 0.85. This is your final answer. This is the probability of Ronaldo winning, regardless of who win, regardless of the game, how many trials. It's for the entire penalty rounds. The probability of Ronaldo winning is this. Okay, I hope that makes sense. Now coming to the very last question that we have here. So in Ludo, it's a game. Prashant needs to repeatedly throw an unbiased die till he gets a 6. What is the probability that he needs fewer than 4 throws? Okay, very simple question. Let's take a different pen. So Prashant keeps throwing a die until he gets a 6. So what is the probability that he gets a 6 in less than 4 throws? Okay, which means he can get 6 in throw 1, throw 2, throw 3, throw 4. Not 4 because he needs to get it under 4. So it's throw 3. Okay, the chances of rolling a 6 of getting a 6 here, P6 is, as you know, is 1 over 6. Not getting P6 it's 5 over 6. Okay, so what are the winning scenarios? Winning scenarios is he gets either throw 1, throw 2, throw 3. So what's the probability of getting throw 1? He throws and gets a 6. That's 1.6, 1 over 6. What's the probability that he throws and gets in the second one? Throw 2. So getting in throw 2 means he missed the first throw, which is 5 over 6, and he won the second throw, which is 1 over 6. So the total probability is going to be 5 over 36. Now, what is the probability that he goes and gets in the third time the charm? So he misses the first one, he misses the second one, but in the third one, he got lucky and received 25 over 216. So what's the total probability? You do a decimal, and then in decimal, you get 0.4213. This is the logic. This is your answer. So all in all, I hope this was pretty straightforward and this makes sense. And moving on, we will solve some more questions regarding geometric series and binomial probabilities. Thank you.